Morning, children. Today our next topic is representation of irrational numbers on the number line. In this topic we'll try to understand the representation of non-perfect square root numbers, also known as irrational numbers, on the number line. And before going on this topic, let's understand a simple concept of Pythagoras theorem, and which states that if ABC is a right angle triangle with AB, BC and AC as the perpendicular, base and hypotenuse respectively, with AB equals to x units, BC equals to y units, then the hypotenuse of the triangle AC is given by a square root of x square plus y square. So here we have a triangle ABC and then AC. So AC is the hypotenuse because it is opposite to the right angle. This is opposite to right angle B. Okay, so this is the longest side AC. So AC square equals to AB square plus BC square. Okay, so we have taken AB as x units and BC as y units, so that becomes x square plus y square. And you keep just AC, the length of AC, then the square root x square plus y square. So hence here the value of AC is x square plus y square. Now for constructing irrational numbers, what is the basic idea we need to keep in mind? The basic idea is we are talking all about the square root numbers, isn't it? The square root numbers, that is irrational numbers. So here suppose we have a square root of 2. For example, a square root of 2 we need to construct on the number line. So what we need? Under the square root we need 2. So to get 2, what could be the possible values of x and y? I mean the base and the perpendicular, what could be the possible values? So here if you take base as 1 unit and perpendicular as 1 unit, then you will definitely get a square root of 2, isn't it? You'll get a square root of 2 easily. So let's check these steps of construction here and see how much you understand from here. I hope you understand all. Draw a number line and mark the center point as 0. Mark right side of the 0 as 1 and the left side as -1. And we won't be considering, after marking right side of 0 as 1 and the left side as -1, we won't be considering -1 for our purpose, remember, because we need the positive ones. With same length as between 0 and 1, draw a line perpendicular to point 1 such that this new line has a length of 1 unit. I will be explaining with the help of construction also, so you can have your geometry box ready with you. Now join the point 0 and the end of new line of unity length. A right angle triangle is constructed. So this is what these steps of construction so far. And then another we have, now let us name the triangle as ABC such that AB is of the height that is perpendicular, BC is the base of the triangle, and AC is the hypotenuse of the right angle triangle ABC. Now length of hypotenuse, that is AC, can be found out by applying Pythagoras theorem to the triangle ABC. So AC is equals to, AC square is equals to AB square plus BC square, and AC is equals to what? A square root of what AB you have taken? 1 unit. So 1 square plus BC, again 1 square, which is the perpendicular. Now this becomes a square root of 2. And finally we have got AC as a square root of 2. Okay, now after getting a square root of 2 as AC, which is hypotenuse, now with AC as radius and C as the center, cut an arc on the same number line and name the point as D, because we want a square root of 2 on the number line, not above it. So what we have got here is the hypotenuse. This is what the hypotenuse is. Since AC is the radius of the arc, and hence CD will also be the radius of arc, whose length is a square root of 2 here. And D is the representation of a square root of 2 on the number line. So let's see step by step here. Need to draw the number line first of all. After drawing a number line, what next to be done? Mark a point A, which is 0, on this line. Mark a point A. So this is A, which is taken as 0. Now they were considering regarding 1 unit. Okay, so you can take 1 unit as 2 centimeter, because if you take 1 centimeter, the arc length will be quite small on your compass. So what I consider here is 1 unit equals to 2 centimeter. 1 unit equals to 2 centimeter. So I'll be taking a radius of 2 centimeter with center A, cut an arc on this line L. So see, this is B now. So AB we got here as 1 unit, which is equals to 2 centimeter, but take it as 1 unit only. Now construct a right angle from point B using your protractor. So after constructing a right angle, it will look like this. And then mark a point C with 1 unit length. Again 2 centimeter arc you are set on your compass, and then mark it as point B here, C here at this particular line C. Now join AC. So AC will be the hypotenuse. After joining AC, this will be the hypotenuse now. Okay, we're done. So BC is 1 unit and AC is, after applying Pythagoras theorem, it becomes square root of 2. Okay, which we have done already. Now the next step is, I want this square root of 2 on the number line. So what do? You measure the length of AC using compass, and then drag from C point on the number line, towards the number line, just drag it. Or you can simply measure it and cut an arc taking A as the center on the line L. So you can do either by this way, cutting an arc like this, or simply just cut a simple arc like this. Okay, and then mark it as C. So AC, or you can write D also. C is already there, so you take another letter D. So D is the point of square root of 2. So the measurement will be AC is equals to AD, which is nothing but a square root of 2. This is how we represent a square root of 2 on the number line, children. This one's the clear picture here. You can see the diagram. Okay. You can choose different letters also. And for other square roots like a square root of 3, square root of 5, square root of 7, square root of 11, make sure that you should get the base and perpendicular with that value. After squaring and then adding the numbers, you should get 3 or 5 or 7 or 11. What I mean to say here is, decide and think of the base and perpendiculars only. Okay, think of the base and perpendicular. If you get the matching base and perpendicular, you get different types of options also, and different types of matching numbers where you square it and add it, and after that you get either 3, 5, 7 and 11. For example, for a square root of 3, we need to have the square root base as a square root of 2 square plus 1 square. So this will give you a square root of 3. For 5, you can take either 3 square, a square root of 3 square and a square root of 2 square, this as the hypotenuse, or you can take simply 2 square plus 1 square. This also works. So go by the simplest ones. So square root of 3 can be represented like this also. The moment you got OA as a square root of 2, take this OA as base and then draw perpendicular from point A. Okay, from point A draw the perpendicular and then it will reach till E point. So here AE equals to 1 unit, and then after applying Pythagoras theorem on OE, which is the hypotenuse here you see clear, OE is hypotenuse, so OE square equals to OA square plus AE square. So this will result to square root of 3, and then again drag it from this point. After dragging from this point to here, it will be square root of 3. Okay, I hope this is clear to you all. You can practice on square root of 7 and 11. That's all from today's class. Thank you and have a nice day.